will discuss about the computer organization and architecture, and I will introduce the COA. Okay, so why we're going to study the COA? So we have to aware with the what is the difference between computer organization and computer architecture. We can answerable about this thing. What is the difference between computer organization and computer architecture? One, and understand the units of measurement common to the computer system. We also want to appreciate the evolution of the computers, like from the starting, how the computer is, what is the first generation computer, second generation, fourth generation, likewise up to today's date. Okay, we appreciate the evolution of the computer. Okay, fine. In this way, to understand the computer as a layered system. It's not a single unit. It's so many layers. When we talk about the computer, a computer that is in front of you, it's not just a single device. It's a layer of the device. Like there are various layers of the system. Okay, and be able to explain the von Neumann architecture and the function of basic computer components. Like specific architecture is there. We will discuss in the next, like in the next slides, that how we could explain the von Neumann architecture, like how the von Neumann architecture work and why it is required, and the basic computer components we need to understand. So by just studying this computer or architecture, so we can answer this particular. These are the set of the things we can answer about. We can answer on this particular things. The computer architecture and organization overview. If we talk about the modern computer is an electronic, digital, general purpose computing machine that automatically follow the step-by-step list of instruction to solve the problem. Now, this step-by-step list of instruction is also known as the computer program. But we can see over here two things. One is a machine and one is a set of commands. Okay, the set of commands are in the form of instruction, and the set of commands are given to the digital machine that will actually compute the commands. Now there is a big question: why we need to study the computer organization and architecture? Actually, you have to understand that there are two things. One is a computer architecture, another is a computer organization. So when we study the computer architecture, so it's more studying about the instruction set architecture, what are the instruction support, how the how the various blocks of the architecture are organized, what are the steps to execute a particular instruction. Those kind of things are the part of architecture. And when we move, or so when we jump from the computer architecture, or when we jump outside from the architecture, at that time, whatever things we have, okay, in the form of computer architecture, that computer architecture tries to communicate with the external world. So for the communication with the external world, organization required. The computer architecture is there, and various peripheral components are there. How these components are organized, and they make all in all a processor. Okay, they make a one particular processor. So after studying this particular thing, this the entire subject COA, okay, we could answer that. Also, we can write a better programs, including systems compiler, operating system, and device driver, where you you have it's required to have a knowledge of the computer architecture. Otherwise, it's difficult to optimize the codes, compiler codes, operating system code, or device driver codes. Okay, and we want to optimize the behavior of the code. Third thing is the we can evaluate the computer system performance. Okay, if we understood this computer organization architecture, then we can evaluate the trade-offs like time, space, and price. So the intention behind studying this particular subject is we tries to become more comfortable with the computer architecture. Okay, we can understand the things, what exactly the things are. When we talk about the computer organization, so it encompasses all the physical aspect of the computer system, like computer design, control signals, memory types, okay, and the ultimate intention is how does a computer work. So by studying this particular computer architecture and organization, we could answer this particular question. Okay, moving to the next slide. The focus on the structure, like in which the components are interrelated, and the behavior of the computer system, and refer to the logical aspect of the system implementation as seen by the program. So, the ultimate intention is how these components are interconnected, how the particular signals are getting high or low. All these things you can understand when you understand the computer architecture and organization. It's a computer organization and architecture. Okay. Now, specifically, if we discuss about the computer architecture, so computer architecture is based upon the instruction set. Okay, IS instruction set architecture. So the instruction set formats, operation codes, data types, number of types of the register, addressing mode, main memory access methods, and various IO mechanisms are focused when we talk about the computer architecture. So the computer architecture of a system directly affects the logical execution of the program. Okay. So when we logically execute the code, so it is just based upon the architecture of a system. It's according to the architecture of system. And the computer architecture for a given machine is a combination of its hardware component plus its instruction set architecture. Okay. So the ISA is the interface between all the software runs on the machine and hardware components. Okay, the studying the computer architecture help us to answer the question, how do I design a computer? Okay, so by studying this particular thing, we can answer how we can design a computer. Okay, in the case of IBM, Sun, and Intel ISS, it is possible to purchase a processor which executes the same instruction from more than one manufacturer, because these manufacturers are different, but they are running on the same ISS. So, any one of the ISA, we can use it. We can use it for the basic instruction purpose, basic instruction set execution purpose, not for the organization, because it may happen that IBM process having different organization, Sun process having different organization, and Intel process having different organization. You can perform the arithmetic operation that is not depend upon the organization. Whatever instruction that is not depend upon the organization, those instructions we can run any of the processor like IBM, Sun, or Intel. But if we want to communicate with the external world like peripherals, memory, in that particular case, we have to study each and every processor, because in this case they all are based upon the single processor, but the organization family is different. So the organization and architecture enable a family of computer models, same architecture but different in the organization, different drives, performance characteristics. Because if your organization change, your overall performances also change. When furthermore, if a technology change, the organization will definitely change, because there is a what you can encompasses in this in the processor chip that is based upon uh, the fabrication technology. So if we talk about the computer architecture, up till now we have talked about the computer architecture and components. So over here, when you see a computer architecture, the CPU encompasses the ALU, register, and control units. So this is your computer architecture, and how we organize with the memory and input output devices. That is called the computer organization. And when we combine this particular thing, we can have a computer architecture or computer organization and architecture. Okay, so this is our study, our subject. You need to study. You will study this particular thing. So now you can see that the CPU is standalone, memory and I/O devices are standalone. To communicate this CPU with the external world like memory or I/Os, it has to communicate through a physical medium. That physical medium, on-chip medium, is this buses. Like three buses are there, usually data bus, address bus, and control bus. Control bus usually carries various control signals. Address bus usually carry address bus from CPU to memory or I/O devices, and a data bus that carries the data from memory to CPU, CPU to memory, and even same from the input output to CPU, and for the output CPU to output devices. Okay, so this is the basic computer components. Okay, the processor is a interpret and execute the program, the function of the various components. A memory includes cache, RAM, ROM to store both data and program instructions. A mechanism for transferring the data to and from the outside world. So the I/O to communicate between the computer and world, plus to move the information from computer component to another component. Okay, so we can see that this is the computer components of the basic computer. Okay, the computers which large main memory capacity can run large program with the greater speed than the computer having the smaller memories. RAM is acronym of random access memory. Okay, random access means that memory content can access directly if you know its location. Okay, so based upon the location, you can directly access the RAM. Cache is a type of temporary memory that can be accessed faster than RAM. Okay, because it's a technology, it's a faster compared to the normal RAM. Okay, and when we talk about the digital system, so digital system having a discrete input 0 1 0 1 format and discrete output 0 1 0 1 format, and a discrete information processing system is there that work upon the system states, like which particular state a system is. Okay, so according to that, a digital system is designed. And usually when we talk about the digital system, there is what kind of the signal it works. As you know the answer, discrete signals. But the discrete signal having a some particular voltage levels or some level symbol. It's like if it is in the form of symbol, number system symbol. So it work on the 0 and 1. If it is in the form of word, because like when we compare the two quantities, and we found that whether the quantity is or say when we try to compare the equation, so whether the condition match or not match, condition false or condition true, so that is in the form of word. Even the same, if it is in the form of voltage level, so it's a low or high. If it is in the form of switch, we talk about the switch, so it's an on switch or off switch. Okay, so these are the signals. This four things that you are watching, the same, almost same one. And now we will discuss about the number system. So what is the number system? So in the number system, like three type of the digital number systems are there, but basically it's based upon the binary number system. In the binary number system, we have two symbols, 0 and 1. In decimal, we have 0 to 9. In octal, octal we have a 0 to 7, and in hexadecimal 0 to F. Okay. There are various codes are also there. Gray code, binary coded decimal, XS3, ASCII, parity. Okay. In the binary arithmetic, because like we have a binary codes are there, and we can also perform the addition, subtraction, multiplication, division using sign unity. Even though we can perform the subtraction with the ones complement and complement methods, and there are various, even though BCD arithmetic is also there, like addition, subtraction, multiplication, division, and sign unity. And we can also perform various logic operation with the logic gates on the binary number system. Okay. So in the binary number system, we have two components. One is the coefficient, and another one is the radix with power. So over here we can have a number like 97142. Okay, so 2 is having the least power, so it is on the power is 10, because over here we are talking about the number system with the 0 to 9. So it's a decimal number system. So decimal number system having a base 10, and the particular number, that is coefficient, is 2, so having a power 0. Similarly, coefficient 4 having a power of 1. Likewise, we can write up to the most significant number 9, that is having a power 4. Okay, so we can see that decimal number system having power 10, symbols 0, 9, binary number system power 2, base 2, sorry, power 2, base 2, and the symbols are 0 and 1. The octal number system having base 8 and symbols are 0 to 9. Hexadecimal number system having base 16, and the numbers are in the range from 0 to 9 and A to F. Okay, so this is all about the number system.